Hello guys, welcome you all to AI Ki Pathshala and welcome you all to the first session of Pandas DataFrame. As you are aware that we are covering I have started the Pandas bootcamp, and in the first part of my bootcamp, I have covered Pandas series. So there is a complete playlist for the Pandas series. So those of you who want to study from the very beginning, that is from the very scratch, you can access that playlist. And now I'm starting Pandas DataFrame today. So what I will do, I will create a separate playlist for the DataFrame. And subsequently, when I will move in the Pandas section, I will keep on creating different playlists so that it is easier to understand and it is easier to go through the things. And at the same time, I am also making a separate repository, GitHub repository for the Pandas DataFrame. And I will keep on pushing all my code and whatever things I will be discussing in the live session in that repository. So you can go to the description section of the videos, and there I will attach you the link of the repository. And from there, you can download all the codes and everything, all the class notes, everything you can download from there. At the same time, if any one of you wants to join my live session, that too free of cost, you can go to the description section of the video and subscribe my Telegram channel from there. So I used to put the live session joining link in the channel only. So that's all. Now, first of all, let's make one GitHub repository and then we will clone the repository. So let me open you So I have opened my GitHub repository and first create one repository, and let me give it the name of the repositories as pandas underscore dataframe. Dataframe. So this is the repository. This is the repository for discussing pandas DataFrame. Fine. Keep it the public, keep this repository public, add readme file in .getignore, add this Python file. And now for the license, choose MIT license. Fine. After that, just create the repository. Can you see? You can see the repository has been created. Now, when the repository has been created, I would like to add one file here called, let me add this file. Okay. No, I'm not getting, right now I do not need it. So I will add sometime later. Fine. So from here, you can copy the entire code. This URL you can copy. And then I'm going to clone this repository in my local VS Code. Fine. So let's clone it. So I have opened my GitHub repository, and now let's clone the repository. Let's copy this URL, copy paste this URL. It's copying. Let's give it a path. So let's give it a path. I'm giving my live session. Fine. So open this repository. Yes, I trust the author. And I have created the repository that you can see right now. My repository has been created by the name Pandas DataFrame. Now what I'm going to do after that, let's create one file, ipynb file, and I'm giving the name of this file as day1.ipynb file. So my ipynb file has been created. Let's select the kernel, Python environment, I'm selecting this environment. Fine. So now, thereafter, let's add few code cells here. So everything is done. Now let's come to our main discussion. So now my setup is ready. Now I'm going to start this data frame. So let's first understand few things. First of all, welcome you all to our first session on the Pandas data frame. And I must say, this is the blockbuster data structure. This Pandas data frame is a blockbuster data structure in Pandas. And in this section, we will build on our understanding of series to establish a good foundation on data frames. As we will see, a lot of the methods and techniques that we have covered in the Pandas series still apply, but they now come with additional power and complexities. In the first part of this section, we will understand what data frames are structurally, how they are compared to the series, and get plenty of practice building our own, and we will build our own data frames from very scratch. Then we will shift our attention to the brand new data set containing nutritional information on about 9,000 food items. This is also where we will get our first test of cleaning up and preparing data for the numerical analysis, which for better or worse is an indisputable aspect of working with data in real life. When you will be working as a data scientist or as a data engineer or as a data analyst. So, as always, we will go step by step, exploring every concepts like regular expression, several data frame manipulation techniques, and even take small break to cover broader computer science topics like pseudo-random generator. Learning about these things is really very fascinating. You may realize as you will progress through these sections, things may not necessarily be easier. So let me tell you this thing very bluntly. As we will progress through the sections, things may not get easier. But you should trust me, you will get a lot better in the process. I'm very excited to get started. So let's start. So first of all, I'm going to, as we used to do, what is the first thing that we used to do? We used to import some libraries. So let's import the library, import pandas as PD, and then import numpy. How you will import numpy? You will import numpy as import numpy np. Fine. Then run this cell. Fine. So thereafter, let's first understand what is data frame. What is data frame? Question. To understand the data frame, let me first write some Python lists. So let me write some Python lists. So let's say write some Python lists. I am going to create the data frame and we will understand this step by step. But before that, let's create some Python lists. So the first Python list that I am going to create is called the name list, names list. And here I am going to put 5 elements. My first element is like Varun. V-A-R-U-N, Varun. My second element is called, name element is called Anup. Fine. My third name element is called Pihu. And my fourth name element is called Olive. Let's write Olive. Fifth name element is called Mrig. M-R-I-Z, Mrig. And my sixth name element is called Tilda. Tilda. These are my six list of the names. Similarly, I am writing one another list, which is called the ages, and I'm putting the ages of all those names that I have written here: Varun, Anup, Pihu, Olive, Mrig, and Tilda. So let's write the age of Varun as, let's say, 20. Let's write the age of Anup as, let's say, 30. Let's write the age of Pihu, let's say, as 3. Let's write the age of Olive, maybe 23. Let's make 35. And Tilda, let's say, write 45. Maybe something. Thereafter, there is third list I'm going to write. And the name of this list is married. So I'm putting whether these people are married or not. So Varun, false. Let's write false here. Then Anup, let's write false here. Then Pihu, let's write true here. Then again let's write false here. And then write true here. So, sorry. False. Let's write true. So 3 to 5, then again let's write true. Doesn't matter what we are writing. Have to write it anyway. Fine. So this is my third list. Now let's run these 3 lists. So now if let's say I have created this list. Now let's first talk about the series, because I have told you that whatever concept we have studied in this series, all those concepts we are going to use it, and nothing, whatever you have learned has some value. What I mean to say. Fine. Let's write one pandas series. SERIES series. So how you are going to write a pandas series? Let's create one pandas series. PD dot. This is the way we used to create pandas series. PD dot series, and thereafter you used to supply, let's say, names. This thing I want to say, and name is equal to, let's write, give it some name, NAME name. You can see here. So this is how we used to create this series. So let's create this series. So what I'm asking, in this series, I'm passing this names as my first argument. That is a list of names. I'm passing a list of names. And the series name, the name of this series, I'm putting as NAME name. Fine. If you will run this, series will get created. Let's see this series. Let's access this series. So when I am accessing this series, can you see I am getting this series, which is having a name, data type object, and whatever thing I have created here, whatever name I have written here, these 6 names, they are coming in the same order in which my list is there. And here, this is my index 0 till 5. So it is taking default, since I have not assigned anything inside the index. So it is taking a default 0 to 5. This is my series. We know this. Now let's come to the data frame. This is how I'm going to make a comparison. That's why I have first created a series. Now I'm going to create a data frame. Let's write data frame. Let's create data frame. Pandas, let me write it. Pandas data frame. Now I'm going to create one data frame, df. I'm giving it a name df. How to create a data frame? To create a data frame, you have to write pd. pd means pandas dot data frame. Then inside this bracket, what you have to write inside this bracket? In the form of dictionary, there are several ways to create. First of all, I am using the dictionary to create the data frame. Let me give it the name first inside this dictionary. Let me give it a name. And in the form of key value pair, the name should be like names, names, names. Then let's give it an age. Then let's give it a married. So what I mean to say, I want to create a data frame which is having 3 columns, name, age, and married. In the name, this is my key. I'm using key value pairs, and this is the value. In the value, this names is there. This is a list, basically names, ages, and married is a list. Let's first create it, then you will understand in a better way. So this is created. Now let's see what I have created. Can you see? This is my data frame. And you can see this name is coming here. This age is coming here. And this married is coming here. So basically, data frame is nothing. Data frame is a table of data. You can see here, there is a table of data. Fine. That data frame is a table of data that contains a collection of rows. This is my rows 0, 1, 2, 3, 4, 5. This is my rows and columns. Collection of data frame is a table that contains a collection of my rows and columns. And what are the name of my columns? This name, age, and married. This is the name of my column. And these are the values inside this column. Name column has a name values, whatever the name is there. Age column is having a age value, whatever age is there, and married is having the values. And from where this values is coming, I have already assigned it inside. I have already created these 3 variables and I have assigned the same number of values. That is length of this name is also 6, this age is also 6, and this married. Length of all these 3 are same. This should be same. Fine. Simple enough, right? But there's a couple of intuitions about data frames that would be really helpful to develop at this stage. And I will use series as a comparison point. I will use this series as a comparison point to understand the data frames, since that's what we are the most comfortable right now, because we have already studied series. So we are comfortable in series. So I will use that as a comparison point. Now let's come to the first intuition. The first intuition is not like series, which are one-dimensional. You can see series is basically one-dimensional. We have already studied in the series section that series is basically one-dimensional data structure. So it's a series is basically one-dimensional, but data frames are two-dimensional. And data frames have levels, leveled indices, and columns. Data frames have leveled indices and columns. So let me explain you something. So let me write this thing here for understanding purpose. Data frames are two-dimensional. Fine. Whereas series is one-dimensional. This is very important. That's why I've written it. So data frames introduce an additional dimension here, whereas series only had one sequence of values with associated levels. This is called basically the level. This is basically called the level. Name is one level, age is one level, married is one level. These are different levels. But you can see in the series there is only one level, not more than one level. That's why it is a one-dimensional series. Fine. Data frames can and do have several such layers, several such levels, sequences. In like here, you can see name, age, and 3. There are 3 levels here, but here only one level is there. So this is what introduces the second dimension of the data frame. As we will see in the future section, using multi-index or hierarchical indexing along both the index axis and the column axis, these are the things that we are going to understand in the future. We could even accommodate higher dimensional data into data frames. And that's a future topic. Let's not jump ahead of ourselves. So for now, we will be working with two-dimensional data sets. Okay. This sounds very cool. So what do we even mean by a dimension? It's very important thing. What do we mean even by dimension, this dimension? So let's think about this conceptually. If you think of a series, if you think of this series, it extends in only one direction. So this is a series and it extends only in one direction. And let's think about any one of these names. Let's think about any one of these lists. Either you can say names, age, or married. So this is extending if you will consider only name, or if you will consider only ages, if you will consider only married separately. So these are the things which are one-dimensional thing. Even this list is a one-dimensional list. You know this thing. So let's think about, I want to access any one of them when working with series. When I am working with series, I do not need to access all of them. I need to access, either I can access this name, I will make a name series, or I can make an ages series, or I can make a married series. I cannot make a series which is having name, ages, and married, because then then it becomes a two-dimensional, and that's not fit in the series. So when working with series, at most, we would need only one piece of information specifically to select any values in this range. We would need to specify either the index level or index position that we are interested in. So for example, if let's say if we are interested in this PU, let's say if I am interested in PU. So what I will say? I will say index position 2. And we will get the PU. Let's say here in this series, this is my PU. And we know the index position of this PU is 2. So if I will simply call this, I will through this index position 2, if I want to access, I will get PU. Let's do it. Let's do it. If I will write scr.iloc, and iloc is used for indexing. We know this. Access through index position. So I'm getting this PU. Can you see? I'm getting this PU from this series. Now, this is about the series. But now when we look at data frames, if you want to access the name, let's say, if I want to access, let's say this is a data frame, fine. And if I want to access this name PU from this data frame, so now we need to specify the index position, that is a 2. This is my 2 is my index position, fine. Or you can say a row number. This is a 0th row. This is first, second. So this is my second row. And then you have to also mention the level, fine, or column position. You can say level or column position. Or so what is your column position? In this case, if let's say you want to access this PU, so to access this PU inside this data frame, not two things, you have to access it not only by the rows, but you have to access it by row as well as column. So my second is the row position and 0 is my column position. So by specifying rows and columns, only you can access this PU. So let's do it. If let's say, if you will write df.iloc and second is my, let me first explain you this thing. It's better to explain you this thing also. See, like this is my row. This is my row, we know. And this is my column. This is my column. And row into column. That's why it's 2 dimensions. One dimension is the row dimension, other dimension is the column. Here also, if you will index it, indexing will start from 0 only. So this is my 0th index. So if you will start indexing, this is my 0, this is my 1, this is my 2. And if there are any other levels, then also I can index like that. So if let's say, if you want to access any particular value, if you want to access this thing, let's say this. So what you will get? This is at second row and first column. So what you have to mention? Second row, first column. Then you will get this value. Fine. If let's say, if you want to access this thing, so this is at fourth row and second column. So what you have to access it through fourth row and second column. Let's say if you have to access this Varun, how you will access? This is at 0th row and 0th column.
0, 0.
So you have to access it through 0, 0. So is this thing clear? So the same thing I was talking about, that let's say if you want to access this PU, so you have to mention first the row, which I have mentioned here too, and then the column. Column is, the index of column is 0. If you will access this, you will get PU. Can you see? I'm getting PU. Now, let's do one thing. Just saying the index position 2 here is no longer sufficient. That what we were doing in this series, we have to mention only the one dimension. But if you will mention only the one dimension here, that is only the index position, it is no longer sufficient. It's no longer enough because that would return you something else. So let's see. If let's say I am writing this df.iloc and let's write 2. See what I'm getting. What I'm getting? I'm getting basically this thing. This entire row. Pu, age of Pu, and whether Pu is married or not. So I'm getting the name of Pu, name Pu, is Pu married or not married. So if you will simply do this, if you will simply write the index position, so it will give you the entire row that I want to say. Because you are not specifically telling your program through pandas that you want this particular item. You are telling that you want this complete row. So it is giving you the complete row. Do you understand the difference? Fine.
Yes, sir.
So now another way to think about this additional dimension is to realize that now we need to specify more than one piece of information in order to identify a specific data point in our data set. This is another way to say this. A more explicit way to see this change in dimensionality is to compare. Let's say do one thing. Let's write some comparison thing and shape attributes. Now let's do one thing. I'm writing something. Let's write to understand the right now I am explaining you the difference between this series and data frame. So there is one parameter, there is one thing called ndim. This is used to determine the dimension. Ndim is used to find out the dimension. So let's write ser is my series, you know. If you write ndim here, what shall I get? What should you get, Varun? Varun?
Sir, 1.
1. Because the dimension of series is 1. But if you will write df dot ndim, you will get 2. Because my data frame here, because data frame has 2 dimensions. My series has only 1 dimension, but this data frame has 2 dimensions. That's why I'm getting true 2 here. Likewise, so you can see the difference. Series is having only 1 dimension. This data frame is having 2 dimensions. Now let's see. Similarly, there's another thing called dot shape. Dot shape. If I will write this ser dot shape, what shall I get? See, this 6. It means it is having only 1 dimension, that is called the 6. It is having this shape 6,0. So 6 means that we have 6 records in our series. This is simply means this ser is having 0, 1, 2, 3, 4, 5, 0 to 5. That means 6. That means it has only this was a data frame. This series is having 1, 2, 3, 4, 5, 6. This 6 records this is having. This is what it is telling me. That's what it means 6 comma. In the same way, if I will check the shape of my df dot shape, let's write what you will get. You will get 6 comma 3. Why this 6 comma 3? That means it is having 6 rows and 3 columns. Just check it here. Can you say I am having 0 to 5 means 6 rows and 3 column? What are my column? First column is name, second column is age, and the third column is married. So this is giving me the shape. So this is very much clear. Series has one dimension, whereas the data frame is a two-dimensional data structure. Now let's move on to the second intuition. Second intuition is, let me write the second intuition here. Each column, column, in a data frame is a series. So like each of these name, non-name, age, and married is like a series. Fine. So if this is, let's access this data frame here so that. So what I am telling you, each column in a data frame, this is my first column, this is second column, this is, each column is basically a series in itself. So you can also say a group of series or a number of series get combined to create a data frame. You can say like this. Each column in data frame is a series. Each column is a series. Each of these, that is, each of these name, age, and married is like a series. But, and let me write ser here also. So let's write it, run this. And let's look at these two things, that is, look at this data frame and this series. So when you look at these two again, we notice the resemblance between the series and the name column of the data frame. Can you see the resemblance between this series and the name column of this data frame? So this name column of this data frame is basically this series. And which series is this? This is the name series. But in fact, this is more than just a plain similarity in appearance, because series is actually the data structure for a single column of a data frame. This is a data structure for a single column of a data frame. So think of the data frame. You can also think of this data frame as a collection of series put together. Fine. There should not be any confusion till here. Now, let's do one thing. Let me add a few more code cells here. Let's do one thing. If I will write df, which is by data frame dot name, what you will get? You will get all the name present inside this name. So you can see, just like our series above, this just like our series. This is also a basically, we can access this from this data frame, we can access this name. And when we are accessing this name, so it's exactly looking like a series, or it is like, you can see the data structure. This is my series, see, and this is my data frame. When I have accessed the name from this data frame, both are exactly equal. Say here also name is coming data type object, because this is also a one dimensional. When so are you getting my point, what I want to say? So this is the second key concept that I wanted you to explain. So columns in data frames are quite literally series. Now let's look at the third concept. What is the third concept? Third concept is that, let me write here this third concept, unlike series, SERIES series, data frame could be heterogeneous. Heterogeneous. Fine. So you can write this thing like, unlike series, data frame could be heterogeneous. What this means with the heterogeneous? Let's understand this. Let me open this data frame and this series together. Now let's understand. When we worked with series, this series, let's say, we saw that we had the flexibility to provide various types of input. It's like we can, when we have worked with this series, let's say in the previous sessions, in the series session, instead of this name here, you can put whatever thing you want. You can put here as a, let's say, some floating point value. You can put here as, let's say, some integer value. You can put here some Boolean value, anything that you want. So basically what you want to say, series is basically, you can provide various types of inputs inside a series. So you can build a series from integers. You can build a series from floats, from booleans. Let's say anything, my name, age, anything, all kind of stuff. But at the end of the day, this series, whatever thing you will write, this series would have one and the only one data type, that is called the object data type. It doesn't matter what you are writing here. If you are either you are writing this, all the things, all the string values, or you will write some floating values, some Boolean values, or a combination of all those things. But this series would have one and the only one data type, that is, let's say, the object. But the same does not apply for data frames. But the same thing does not apply for data frames. What it means? If we try to, let's say, if we try to access, let's say, if you will try to access the data type of, let's say here, you can see the data, it is already giving you the data type as object. If you will also access ser.dtype, you will get this thing, object. But if we try to access the data type attributes for my data frames, we will get an attribute error. Because this data frame itself don't have any data type. Let's do it. If I will write data frame dot dtype, let's see what I am getting. Can you see? I am getting an error. And what is my error? Data frame object has no attribute dtype. Because data frame itself don't have any data type. Why? Because they are a collection of labeled sequences of values, and that may be of different data types. If you will see here, this data frame, this is a name column, and this name column has a string data type. Let's say this has a string value. This age column, this has an integer value. This married column, this has a Boolean value. And it is a combination of all these columns. So there cannot be any single data type through which you can define this data frame. So what is happening? Each column of this data frame is having different data types. So that's why instead of this df.dtype, what you have to do, if you will do df dataframe.dtypes, types means give me all types of data present inside this, all types of data structure that all types of data structures present inside this data frame. So if you will write df.dtypes, you will get name, and it is giving you name is an object type. It is giving you this name is an object type. This, it will give you integer type. Can you see this age is int 64 and this married is boolean because it is having a boolean. So it is each column will be having its own data type. So you will get these things like this. So so if you will access the data type attributes, so it will return you something like that, returns a series containing column name as well as their respective types. So this is a column name and the respective type of data that is present inside the column. So we get what we say the data types. We get all of that input here in a very nice short series. But if our data frames had too many columns, this is just a beginning. I have framed data frame with 3 columns. But let's say if our data frames had many more columns, so this will obviously will extend. This will get extended. Here also the things will get extended. So the key thing to remember here is that the data frames itself does not have its own data type. Let me write this thing here. Key thing to remember here is that the data frames itself does not have its own data type. Fine. This is very important. Instead, by accessing the data type attributes on a data frame, we get a summary of the types for each respective columns that make up the data frame. Now, to summarize, as we transition from series to data frames, we will notice that a lot of what we have learned about series will carry, and a good bit will be new and different as we explore the power of Pandas DataFrame in this and the subsequent sections. So just now, this is the end of the today's session. I'm not going to extend it now. So just a little recap of today's session. What are the recap? First thing is that series are one-dimensional, whereas data frames are two-dimensional. Second thing is that each data frame column is a series, and data frames could be heterogeneous, meaning they can contain columns of different data types. So this is the end of the today's discussion. Now if you have any questions and doubts, you can also write in the chat window, or you can directly ask the questions. I'm available to talk. Let's push the code. So first, let's write the message first. session of Pandas data frame completed. Find commit. Oh, not commit. Cancel. First save this entire code. Fine. It gets saved. Now commit it. Commit. Yes. Sync changes. Fine. Fine. So that's all for the today. We will continue from this next session. And those who want to attend the live session, you can go to the description section of the video and join the Telegram channel, subscribe the Telegram channel. And that's all, guys. Keep learning, keep smiling, and keep commenting. If you guys are having any doubts regarding whatever session I am conducting, you can definitely put it in a comment section. I will try to answer your questions. I will take your questions during the sessions. And that's all. Take care. Bye. Good night.